Wow, thanks everyone for being here. This is an exciting event. We'll give you all just about 30 seconds or so to come sit down if you feel like it. I'm very glad to be here today. Thanks to PG&E for the invite. My name is Jeff St. John. I'm what's my title now? I'm Chief Reporter and Policy Specialist at Canary Media. Yeah, it's pretty fancy. We're a nonprofit newsroom dedicated to covering the climate crisis and the energy transition. You can find us at www.canarymedia.com, and as a nonprofit, we welcome the financial support of our readers, so feel free to do with that what you will. But that plug aside, I've been fascinated with the stuff that we all were listened to about from the last panel, and really excited by a lot of the stuff that PG&E is doing on that front. So I'm really glad to have this chance this afternoon to talk to Michael Delaney. Michael, you're Vice President of Utility Partnerships and Innovation at PG&E. Can you just tell us real quick a little bit about what you do and what your Utility Partnerships and Innovation team gets into?
Yeah, sure. Well, thank you, Jeff. I'm glad to be here today. So, yes, you said Mike Delaney. I'm Vice President of Utility Partnerships and Innovation for PG&E. So I have the pleasure and the privilege of working with our coworkers that are really focused on decarbonizing our environment and doing it in a way that drives rates down for all of our customers. And that's something that we have a vision of, that when we look ahead, we look at 2040 and we see we have a commitment to get to net zero, and we have a commitment to do that in a way that's affordable for our customers. And so we've done the analytics on it, and when we look forward, we see that we can get 60 to 70% of carbon out by that point. We can do it in a way that is more efficient than today, and we're looking at a way to do that where we're driving total energy wallet for our customers down by 20 to 30%. And so my team, specifically, that's what we focus on every day. We're focusing on delivering that future. And really to do that, there's a few different points that we do, and there's three big things that we focus on. One is accelerating electrification. So that's transportation and buildings, finding ways to bring more clean load on more quickly. The second is really what we think about as load flexibility. We call it load management as well. So finding ways to increase the utilization of our system so that as we bring on more electric load, we are avoiding those peak times so we do not have to build as much infrastructure. And then the third is innovation and partnerships. And so with innovation and partnerships, really what we look at there is finding ways, like really to incubate the next big idea. And I've challenged my team on that when we think about ideas there, we're thinking about ways to differentially drive costs out of our system. So how do we find ways to drive rates down more effectively? So if we're investing $1 million in something, we want to find $10 million of rate reductions from it. So it's a huge focus for us because as we get to this future, the way we are going to be successful is by doing it in a way that's clean and affordable. It has to be both. Okay,
that's really important, obviously the affordability part, because obviously let's talk about the elephant in the room. I mean, PG&E costs are going up. These are the costs of fighting climate change and of adapting to climate change, speaking of wildfire mitigation and adaptation, and of meeting the utility safety and reliability mandates. So rates have gone up quite a bit. This has been in the news a lot. It's certainly a problem for low-income customers who are struggling to pay their bills, and it's a problem for policymakers in Sacramento. PG&E and all of California's utilities and the Public Utilities Commission and Governor Newsom and California lawmakers at large have to all find a way to, in some ways, do more with less or do more with the stuff we've got already in ways that do right by customers and support the societal imperatives of affordability, reliability, and a climate-aligned future. And I think it's also challenging to think about how that kind of aligns with the electrification imperative because, adding all the load that is now being served by gasoline and putting it into EVs and all the energy demand that's being served by, fossil gas and putting it into heat pumps and other electrification is seemingly going to increase the cost of this service. But I think that's not necessarily the case. Actually, increasing load versus optimal utilization of the infrastructure you got can actually kind of spread costs across a wider base. And, you know, in terms of meeting the forecasted demand from electrification, particularly electric vehicles, how do you meet grid needs and do it at a lower cost and at minimal impact to customer rates? What kind of innovation and partnership stuff are you all doing on that front?
No, that's great. Well, let's go back to as well. So we recognize that rates are a challenge for our customers, and we think about this every day. What a big lever for us to continue to drive rates down, and by the way, rates are lower today than they were a year ago. We have to keep that up as we go forward, because really, you know, quite frankly, like, we are at the forefront of decarbonizing and electrifying, and others are not going to follow us if we cannot find a way to do that with lower rates that's more affordable for our customers. And so that's what the utility partnerships and innovation team is focused on. And let me talk about, I'll give you an example of that. So, I mean, one is last year, like, just our team and the things that we did, we looked hard at a lot of different areas, and we actually drove $3 a month out of our customers' bills just from the stuff in our team's work. And we're looking at doing that every day. And we look at this, you mentioned electric vehicles, and let me talk about it this way. So a big lever to drive costs out is to increase utilization of our system. So this is this concept of, like, there's different ways that you can drive costs out. And a big one for us is we have lots of assets out there in the world. So you think about the utility system as a big factory. We have poles, wires, plants. They're all out there, very capital intensive. So a good way for us to drive costs down is actually to utilize those assets more effectively and to get more out of what we have today. So when we talk about transportation electrification, doing that in a way where we're increasing utilization. So it's not about just bringing on load, but it's bringing on load without increasing the need on the peak days. Let me give you 2 examples of how we're thinking about doing that. One is we have our EV Connect program that we've announced with Itron, and what we're working on there is the next generation AMI meter. So AMI 2.0, using that to tackle a real problem that many customers have when they look to electrify. So if you are in our territory and you add an electric vehicle, many customers that do that at home want to add level 2 charging. About half of our customers have 100 amp service panels. Oftentimes when your electrician will come to install the new panel, the new charger, they'll say you need a panel upgrade. If that happens, first that's going to be a cost for customers. So you're going to have to upgrade your panel. It can be anywhere from $3,000 to $5,000, even more dollars to do that panel upgrade. The second piece is sometimes that then causes us to have to upgrade our service transformer. Think about the service transformer as the piece of the grid closest to the customer. It's the can on top of the utility pole near your house. And so it serves somewhere in the neighborhood of 6 to 10 customers. And so at a point, they run out of capacity. And so if that happens, we have to go out and upgrade that transformer. That can cost upwards of $100,000 to add to that. So now we start to see how these costs start adding up. And so our hypothesis and what we're working on there with EV Connect is to actually, what if we don't have to do that whole thing? What if we can just avoid the whole panel upgrade and avoid the service transformer upgrade by dynamically managing EV charging load? Because really the reality is, customers only violate that 100 amp service panel limit a few hours a year in most cases. And so
they have to turn on a lot more than the EV.
It's your EV, it's your stove, your dryer, your air conditioner, maybe all running at the same time is kind of what then causes that to occur. So there are sometimes it happens, and we want to be mindful of our system, and so we need to be assured that we are not going to have customers go over, because what happens if you do, we can have service transformers fail, and then you go out of power, and then we have to go out there on an emergency basis and replace it. And so this program that we're doing, we're out in we've gone beyond the pilot environment or the lab environment, and we're now out in the field working with real customers on this, is a solution to both drive down costs, because then we don't have to do the panel upgrades for customers, don't have to spend that money. We don't spend the money on the service transformers, and it gets you into your vehicle sooner and charging more quickly, because you don't have to wait months for us to get out there to do a transformer upgrade. Right. So that's one great example. I'll give you one other one.
Yeah, yeah, I'd like this one.
All right, so this is on the larger scale, commercial EV charging, similar challenge that we can run into. So sometimes we'll have it where we don't have additional capacity on our distribution system to serve customers. That takes time for us to build out that system. It can be anywhere to a few years, depending on what needs to happen. We've been working with, we have a program we call Flexible Service Connections. We've been working with especially EV charging station providers, think bigger facilities. And I'll give you an example. In Fresno, Pepsi has a fleet of electric semis. And we ran the calculations, and we decided that we needed to upgrade their system. And instead of doing that right away, and so it'll take some time to get there, it'd be like 18 months from now before they could get on. Instead of waiting for that, we were able to work with them on this flexible service connection product, which is essentially using our, we communicate with the customer on the times at which we're going to have peak needs on the system and the peak demand there, and essentially we can throttle back their charging for short periods of time. That allowed us to get Pepsi on more quickly, about 18 months faster. Got 50 electric semis out there in the world. So if you're in the Fresno area, you're maybe getting deliveries with electric vehicles there, and it's working. It's like faster, better, and it's caused us to not have to do that upgrade as quickly.
Yeah, and I think it's important to understand that it's not a question of you can charge all you want versus you have to be throttled at certain hours of the year. It's you can't charge, you have to wait to get the charging capacity that you want versus doing it earlier, which seems like really important because as far as I understand, every kilowatt hour or megawatt hour of charging you're putting into an electric vehicle is a new additional sale of electricity, and the more sales you spread out across a growing new customer base, a bunch of vehicles that would otherwise be filling up with gas or diesel, you're spreading the pool of money you're bringing in, which should lower rates over time for everyone else. The time to power kind of concept here seems really important, particularly when we're talking about all this load growth that may or may not emerge depending on broader economic issues that are beyond our control. But there is, I think, that's a really important point about adding new load, especially electrification load. I wanted to bring us back to some of the conversation that we heard in the last panel that has to do with utilizing the assets that are being deployed by customers. And let's start with talking about kind of equitable access to the values that these devices that customers are paying for or that are financing through third-party vendors can provide to the grid and the utility at large. We could start with rooftop solar, which of course is a controversial topic, and we're not going to get into the issue of on this stage right now about net metering or whether or not rooftop solar owners ought to pay more of a fair share, or whether the share that they are being paid is fair on its base. This is a complicated thing. A lot of people disagree with the utility framing on this and point to net benefits of customer-owned solar. And there's a vigorous debate, to put it mildly. But I think one could probably argue that the next incremental unit of solar on the California system is less valuable than it was 10 years ago. But there's, I think, an important value to be ascribed to the unit of additional solar that can be put into a battery, for example, to be saved for those peak hours that we were talking about. There's a value to be ascribed to the unit of customer-generated power that can feed a new customer electric vehicle or heat pump, particularly if it can be shifted into the hours when, if that load and that generation can be married up in times when there's, not so much, demand, or there's more demand on the grid at large, right? You're reducing the peak. It's all about that capacity utilization. And these are really complicated issues having to do with how you figure out what it's worth to everyone for individual customers to do stuff and what it's appropriate for the ratepayers and the utility to offer those customers for doing those things. Sorry, that was a long, complicated sentence. But let me ask you about how you and your team are working on taking on the costs of engaging in, climate reliability and electrification imperatives that help value the stuff that people are putting their money into that interacts with the grid at large.
Well, Jeff, we could spend we have to do a whole nother fireside chat on that whole topic. So maybe I'll go two places here. So one is we spend a lot of time as an industry talking, debating, quantifying what we think the value of distributed resources are. Proceeding after proceeding and legislation, other places like that. What we need to spend more time on, and I'll talk a little bit, and Yang actually mentioned this earlier today, a pilot that we're doing with Sunrun and SPAN. We need to spend more time realizing the value. Not just theoretical value about, you should get paid this and this and that. It's like, it needs to actually perform. And for me and my team, we think a lot about, we need distributed resources to be trustworthy assets for our operators, our planners, our engineers. Like, if our engineers do not trust that a virtual power plant is going to perform, that's a problem. Then we'll have to think about how can we operate our grid effectively if we're not sure that it's actually going to be there when we need it. And so the work that we're doing this summer with SPAN and Sunrun is on actually testing this out. Let's actually test out an aggregation of resources and see if they can respond in the way that we need them to respond to specific signals on our distribution system when we need to call it there, specific circuits, and when you get down to it on the transmission system as well, and so different points there. And the points in time in which we will need those assets for those uses will not always match up. It will not always be from 4 to 9 when you might see a lot of the needs on the bulk system level. Sometimes it'll be at 11 a.m. in the morning. Sometimes it'll be different places because we have a great diversity in our system. And we have 3,400 different circuits across our system, 5 million customers on the electric side. And so what is needed in Bakersfield on a given circuit is very different than what's needed in Yosemite. And so getting down to that granular level and seeing that it actually works is a huge thing we're focused on. We'll continue to have the debate about quantifying it and figuring that out. And so that is something that we need to continue to do. But I will say the other quick point I'll make on this, and point number 2 is part of this as well is we need to, in my view, reframe kind of how we think about distributed energy resources. And so a lot of times we talk about it as an industry as almost like a premium consumer product. They need to be cost effective. We need to drive costs down. How do we get the most cost effective product? So if you take the V out from the front, so VPPs, you just talk about power plants. We've got great ways in which we focus on driving costs out of power plants, by finding ways to deliver the same value as cost effectively as possible, to drive prices down, competitive solicitations, market structures. We don't yet have that same discipline and that same focus when we add the V on front. And so that's a huge focus for us as we think about the future and driving a clean and affordable and resilient future. It's about decarbonizing and doing it in a way that drives cost and rates down.
Yeah, and that makes sense. I remember I was talking to one of your colleagues about that program you mentioned with Sunrun and Span, which is a smart panel company that basically can control all your stuff behind a single kind of smartphone-enabled panel. And it's really important to be able to figure out, let's say you're going to say that 100 houses are going to agree to control how much electricity they're using so that we don't have to upgrade a part of the grid serving them. It's very important, obviously, to be able to prove that those devices are going to be able to do that, and that customers won't override them because, or if customers are going to override them because maybe they have an elderly relative who really needs that air conditioning, that there is enough diversity of customers at the end of that circuit so that a few people doing the unexpected isn't going to mess up the necessary load reduction to avoid the safety problems that are going to emerge if those people don't drop their load enough to make it okay that you didn't put that transformer or upgrade that line and stuff like that. That's super important. On the other hand, I could imagine that there are a lot of folks in the distributed energy resources side of things who would say that perhaps the traditional mechanisms by which utilities and regulators determine the cost effectiveness of traditional resources versus these novel resources has lagged behind the capabilities of the technologies and the cost-effective application of the technologies. This is complicated stuff, but it does seem, I know that we've been tracking proceedings at the California Public Utilities Commission and pilot programs that have attempted to do this. There was a big DERMS round of pilots back in 2015, 16, 17 that kind of fell apart because you couldn't get enough customers to sign up, and then all the stuff that they were deploying didn't really talk to all the other stuff that was going on. But I think these problems are becoming it's not as big of a problem, or that is the technology is evolving to the point where one might expect that won't be as big of a problem in the future. But we have kind of an urgency here if we consider load growth, if we consider the need to electrify so much stuff and serve that electrical load. How do you guys, and you mentioned that power plants are a known and reliable commodity, but they're also kind of a chunky commodity. And they take years to plan and develop. How do you guys consider the value of distributed energy resources as a more modular alternative to that stuff? How do you value the optionality of DERs or a integrated distribution system planning approach in light of the great uncertainty about where the new load is going to emerge, how quickly it's going to emerge, and how quickly one can build the bulk system to kind of support it?
Yeah. Okay. I don't know. I'm not going to give you like a great answer on this. I'm going to go in a couple of different directions here. One is, I mean, it comes back to how much we can trust the resources. And I'll give an example we had last year. So, and this isn't criticism of anything. There's a company, Enel, if anyone knows, the European utility. They had a charging station, electric vehicle charging station manufacturing company. They were an OEM for that, Juicebox. They decided to exit the North American market. We have thousands of Juicebox chargers in PG&E territory. And they were smart chargers, and now they became dumb chargers overnight when Juicebox left. And so that's a challenge for us because we were relying on those resources to be there. And when they shut the API off, all of a sudden it's not there.
Because they didn't really speak the language they were supposed to be speaking.
Right, and so it gets to this question of standards and interoperability and our ability to continue to rely on those assets independent of business decisions that various OEMs will make over time. And so, that's a piece of it for us is as we look to distributed resources, it's both about, like, we want them to be there for the long haul, and I totally believe, like, there's great value and great opportunity in VPPs, in distributed resources, in both providing better value for customers, but also doing it in a way that provides a more cost-effective energy system overall. And it's us working together with our partners and technologists and others in the industry to find ways to drive that future.
Yeah. I might jump to the resiliency side of things, because it does kind of, I think, it's kind of the crystallization of what distributed energy resources can do when they become the main focus of reliability. And that's kind of talking about wildfire, mitigation and adaptation. I know that PG&E obviously has a very clear responsibility to minimize the threats of wildfires sparked by its grid. And PG&E has had well-documented issues with this. And PG&E is planning to spend a lot of money on some bulk system approaches, undergrounding power lines and stuff like that. But there's also the need to sometimes turn off the grid if things are getting dangerous. And we saw there's an ongoing investigation in Southern California about that right now, which means that it's possible that in some cases, the safe thing for everyone is going to be to ask people to go without power for some amount of time. This seems like a place where distributed energy resources could play a very valuable role. The question is, how does one establish that value, and how does one go about determining that if the utility is spending ratepayer money on it, that it is benefiting both the folks who are being supported by it and kind of leading to a ratepayer-wide kind of, cost-benefit equation that's in the positive territory. But I think you guys are working on some remote microgrid type projects that might start to help us answer that question.
Yeah, let me speak to that. And so, clearly wildfires are a thing that we focus a lot of our time on mitigating, preventing, which is really a sign of climate adaptation, that we are adapting to the climate we have in Northern California. And we continue to invest a lot of time and resources and effort in finding ways to take risks out so that we are making our system as safe as possible and that we do not have catastrophic wildfires. One of the most effective tools, the most effective tool we have for that is undergrounding. We have layers of protection that we have created in our system, whether it's remote sensing, AI, and other things. We have also continued to apply innovation to find ways to mitigate, prevent ignitions, but then also mitigate the consequences of those ignitions. And one of the most effective tools as we think about our layers of protection is actually this innovation we had called enhanced power line safety settings. And so what that is that we are able to very quickly trip off a line. So if a twig or a squirrel or something hits a line, we can very quickly turn that off in a tenth of a second. And that helps prevent there being as much energy on the system to prevent a fire. What that does is that creates an experience for customers where you will experience more outages if you're on one of those circuits. And so we have customers that experience 10, 12 more outages a year because of this. And it's something we are going to keep doing because it keeps people safe. One of the things that we have then done, one of the things my team is working on is actually deploying batteries for some of those customers. So, so we are deploying batteries in customers' homes to help prevent, or to help kind of mitigate the impact of those outages, especially for customers that have medical devices or other things like that. We will get out there and install a permanent battery like a Tesla Powerwall, or other manufacturers have devices like that out there. That's step one, and we need to do that. The next piece of this, what we're now working on, is how do we strip costs out of this? How do we make this better, faster, cheaper for our customers? And so the next step here is we're looking at how do we get load management out of this? So we know when we turn on these enhanced power line safety settings. It's a part of the year that we do that during wildfire season. When we're not in that mode, there's capacity on those batteries to provide grid services, to do other things. And so we're unlocking that value to help drive costs down. So that's part of what we look for, is those opportunities to both provide better service, but do it at a lower cost and find ways to keep on lowering it every day.
Right on. Well, I will leave to you and other folks in the audience any discussions afterwards about how folks who are bringing batteries to the market might want to give you guys some of that service. But I think we're out of time, actually. So let me ask you, Mike, to kind of leave us with some parting thoughts, essentially around PG&E's kind of broad-based kind of R&D strategy, and how you all are kind of looking to folks who might be representing, companies or community organizations or anyone else in this audience about how they can get involved.
Great. Two things here. One is just going back to the beginning, as I shared, our 2040 commitment is getting to net zero and doing it in a way that's more affordable for our customers. And so we have a commitment, and we've done the math that we can do it in a way where we're driving carbon out, we're lowering the total energy wallet for customers, and we're having more efficient use of energy. And so we can't do that all ourselves. We need help. We know that we have gaps there. And what we've done, if you go to pge.com/innovation, you can see our R&D strategy report. We've opened it up to the world and said, here are the problems that we have, the gaps we need to solve, that we want to invite the world's innovators and entrepreneurs to help us solve. 67 different problems on there, which is probably too many, and we're continuing to work that down to like, hey, here are the ones that are going to be the biggest impact, the ones we really have to work on. And it's, I will just keep on coming back to our focus is on cost. And so it has to be an and, where we are decarbonizing and doing it and driving costs down, putting downward pressure on our rates as we do it. And so every time when you come to me and you have something, don't just talk to me about the value, tell me about how this is going to strip costs out from our system. And so that's what we invite you all to do, and we're in it together. We're going to make it happen. And when we do it here in California, we're going to show the way for the rest of the world and the country to have a healthier planet, to do it where we're decarbonized and a more affordable future for all.
All right, let's get it done. Thanks, Mike.